Number 106, we are given two polar curves and their graphs. These graphs are occurring when theta is 0 up to theta equals pi. And when theta is 0, both graphs begin here and move in this direction. We can verify those things just by plugging in some values of theta and saying that, yep, as theta moves from 0 to pi, these graphs move from 4,0 to negative 4,0 eventually. All right, and then part A, they ask us for dx dt when theta is pi over 3. And they're asking specifically for this curve, R2. So we know that the x is r cosine of theta, and therefore x is equal to this function of theta, and dx d theta is what they're asking for. Dx d theta will just be the derivative of this function with respect to theta. So we'll have to use the product rule where the green function is being multiplied by the blue function. Using the product rule, the derivative of the green times the blue plus the derivative of the blue, which is a negative sine of theta, times the green. And what is that value when theta is pi over 3? Let's plug pi over 3 into this entire expression. So we're left with that after we substitute in pi over 3, and this simplifies to that, which is 15/4 minus 2 root 3. So dx d theta, when theta is pi over 3, is 15/4 minus 2 root 3. Onward to part B. All right, they're asking about the distance between the curves when theta is between 0 and pi over 2. So that's just quadrant 1. We can see that R1 is further away than R2, so we could say that the distance between these curves is that distance minus this distance. Or in other words, 4 minus that expression. And that simplifies nicely to a distance of just 3 sine of 2 theta. All right, so that is the expression for the distance between the curves for theta values between 0 and pi over 2. Next, they ask us to find the rate at which that distance is changing with respect to theta at theta equals pi over 6. So let's take the derivative. The derivative with respect to theta of 3 sine of 2 theta is 6 cosine of 2 theta. So if we evaluate that when theta is pi over 6, we get our final answer of 6 times cosine of 2 times pi over 6. Or 6 times half, or 3. So it's changing at a rate of 3 units per radian, because we're doing d distance, d theta, so the rate of change of the distance in distant units with respect to the rate of change of theta, which is in radians. So 3 units per radian is how fast it's changing, which seems pretty fast. Regardless, that's the answer for 106 part B.